You are welcome to GMAETS 41 live class. In this class, I'll be teaching you dimensional analysis. In our previous physics class, recall that I introduced you to the very beginning of physics in preparation for the 2025-2026 academic session. That's just to kick off, in a few weeks from now, because of course it's going to be September, October. And then I taught you the concepts of physical quantities and their units. We talked about quantities being divided into two. We have fundamental quantities and we have derived quantities. So in this class, we are going to be given attention to the dimensions of these quantities. Once again, you're welcome. If you're yet to subscribe to this channel, hit the subscription icon right away. Don't waste time. After you subscribe, you'll see a bell icon just beside. Tap on that bell icon. You'll see a menu show up. Select all, so that whenever GMAETS 41 upload any content, or whenever I come on live like this, you will be personally notified. This is Chukwu Joshua. You are welcome to the class. Once you just join, as always, like this class and send the link, share the link to this live class to your friends, to your departmental WhatsApp group, to people, your friends you know who are preparing for 100 level academic section of 2025-2026, soon to kick off. Those who are preparing for JAM, for WAEC, all right, next year, 2026. All of these ones, they need this class. Even those that are just entering grade 10. In Nigeria here, we call it SS1. Okay, those in SS2, those in SS3, that's grade 10, grade 11, grade 12. They need this because in your professional examination, you know that you will be tested on questions obtained or extracted from this topic. Dimensional analysis. We are going to start this class first by defining the term dimension. What is the dimension of a physical quantity? We are going to define it. All right, after which I will pass the message from the International System of Quantities. That organization sent me to deliver a message to you. What is dimension of a physical quantity? By definition, the dimension of a physical quantity is a way of expressing that quantity as product of symbols raised to given powers. Once again, the dimension of a physical quantity is a way of expressing a quantity as product of symbols raised to given powers. Now, there are two key points in this definition you want to take note of. And what are these two key points? One, that whenever you are dealing with the dimension of any physical quantity, you express this dimension as product. Product of what? That brings in the second important term in this definition. Product of symbols raised to certain powers. So I think there are actually three key terms in this. Please permit me to check the network situation. All right. Like I've always told you, whenever network disturbs, we are going to boost the network. Are you following, right? So let's see. You want to always be patient, please, because of network situation here. I think I have to boost the network a little, please. Good. Please, I've always appealed to you on the challenge regarding network. Sometimes network might just go down. You want to be patient. Once it happens, I have my own way of trying to boost the network. So I boost and see. Whenever the network goes down, you might be automatically logged out. Don't tune out. Stay on. Once I boost it, you'll be logged in automatically as well too. Okay, so let's see how far we go. The network is really poor today because of the weather situation. All right, I just defined dimensional analysis, and I am trying to highlight the key points in that definition so that you would understand what the dimension of a physical quantity is. We define it as a way of expressing a quantity as product of symbols raised to a certain power. I don't know, is the network still disturbing? This is not coming up. This is not coming up. So I just hope. Trying to use this device to track what is happening there. But I just hope it's the network on this device anyway. So maybe once a while I will check through the camera, okay, to know. Now, when we have defined this dimension, okay, I've defined it, and I want to highlight key terms of interest. Key terms of interest in this definition. One, you want to take note that whenever you're talking about dimension of any physical quantity, we are interested in certain symbols. We are interested in certain what? Symbols. Now, the symbols will be raised to powers. The symbols will be what? Raised to powers. The symbols will be raised to what? Powers. That is another important term in that definition. And then when you talk about the symbols, we actually multiply the symbols. We multiply the symbols. That is why the definition say is a way of expressing a quantity as product of symbols. So product or multiplication of symbols. These are key things. Key terminologies in that definition you want to take note of. Product or multiplication of what? Symbols raised to powers. I have defined the dimension of a physical quantity. Now, I want to deliver the message from the ISQ organization, the International System of Quantities. Okay, the message that I was sent. In the study of dimensional analysis, there are these quantities whose dimensions you are not expected to joke with. These quantities, there are just 7 of it. There are 7 of them, right? And these are the dimensions of fundamental quantities, the dimension of base quantities. Recall that in our last class, I taught you fundamental quantities. I also delivered this message to you that these 7 fundamental quantities, the International System of Quantities expect you to memorize them. In the same way, in the study of dimensional analysis, dimension of these 7 fundamental quantities, you are expected to memorize them. So at this point in time, as I deliver this message to you from this organization, I am going to write the 7 fundamental quantities on the board and their dimensions. Okay, so let me check the network situation via the camera. This device is down, so I don't know. I need to know what is happening to the network over there. Okay, can see some of you friends still connected. That's good. Fantastic. BJKLI. All right, I hope you are following up. Janda Mark Ayuman, you are welcome to join the class. Do I need to boost the network a bit? Okay, I think the network is still okay. Let's see. We shall now look at the 7 fundamental quantities. I am going to be fast, no time to waste on them, please, because these are basic aspects of dimension. I am actually targeting the concept of applications of dimension. That's really what I'm trying to target in this class. So let us look at the fundamental quantities. Fundamental quantities. Okay, and then we are going to look at their dimensions. Dimensions. Like I said, you are expected to memorize the dimensions of the 7 fundamental quantities. So the first we are going to start with mass. What is the dimension of mass? It is capital N. Then 2, we are going to talk about length. The dimension of length is capital L. 3, we have time. The dimension of time is capital T. The 4th fundamental quantity we want to talk about is current. The dimension of current is capital I. Next, number 5, we're going to talk about temperature, thermodynamic temperature, or simply temperature. The dimension of temperature, we use the symbol theta for it. Number 6, amount of substance, which is the mole. I'm simply going to leave it as amount. Simply going to leave it as amount. Amount of substance, the mole. The dimension is capital letter N. And then the 7th one, luminous intensity. Luminous intensity. What is the dimension of this fundamental quantity? The dimension is J. So these are the 7 fundamental quantities and their dimensions. Physicists expect that you know these 7 fundamental quantities. The International System of Quantities, ISQ, has sent me to inform you that as a student learning the concept of quantities in physics, you are expected to know these 7 fundamental quantities, know them, memorize them, because when you now move on to other quantities, which we shall soon move on into, where we talk about derived quantities, those quantities are obtained from fundamental quantities. Just like we learned under derived units. You know, we stated that derived units are obtained from fundamental units. So once you know fundamental units, it becomes easy. It becomes simple for you to handle derived system international units. In the same way, once you've learned fundamental quantities, their dimensions, it becomes easy for you to handle, for you to derive, for you to establish the dimensions of derived quantities. So take down this. Let me check the network situation, and then we are going to move on to derived quantities. Mary Cynthia, good afternoon. You're welcome to join the class. You're welcome to join the class. I hope you're fine. All right, so believing that you've written these 7 fundamental quantities, I am going to go right away to talk about derived quantities. No time to waste, okay? We are going to look at some derived quantities. We are going to look at some derived quantities. Please, you are meant to memorize these symbols. These are the symbols of fundamental quantities. You don't use any other symbol for them, apart from these ones. These symbols you have here on the board are standard. They are what I said, standard. And I think generally accepted, around the world as symbols we use. And now in the study of dimensional analysis, although there are 7 of them, are you following, right? Although there are 7 of them, but you see 1, 2, 3, and 4. They are the ones we usually encounter in our studies. You may still see other ones, but 1, 2, 3, 4 are the ones we usually encounter. Then out of this 1, 2, 3, 4, that is the dimension of mass, length, time, and current. The first 3 are the most significant of them. Most times, these are the ones we meet. The dimensions of mass, the dimensions of length, the dimension of time. M, L, T. But this one of current, important also, so that whenever you're dealing with electrical quantities, at least in our class today, we are going to establish the dimension of electrical potential. Okay, so let us move on to derived quantities and their dimensions. Okay, derived quantities and their dimensions. So I have derived quantities. You know, the list of derived quantities, the list, the number is how do I put it, right? We don't have numbers for them, okay? You cannot exhaust derived quantities. There are so many of them. So we're just simply going to pick some. Just touch, pick some of them and analyze. It is believed that from what you're going to see, you can now be able to establish the dimension of other derived quantities, because we cannot cover all of them. That's the truth. Let me check the network situation. I hope you're still following, right? And I hope the network has not cut you off. Once you join the class, please give this live class a like and then immediately share the link to your friends so that they can join. On this platform, GMAT 41, this is where you have the best opportunity to learn most of these things, you know, in a way that seems as if it is a primary school subject brought to you friends, you know, in higher level to learn. At school, most of you don't have this opportunity. So make use of this online platform, this online school, to improve yourself. Now let us move on. The first derived quantity I would like us to talk about is area. Because these guys do not have, should I number them? Do we have to number them when they don't have lists? Anyway, let me just number. Let's go to area. What is the dimension of area? Usually, for dimension of a given quantity, we enclose that quantity in square brackets. Take note. So for area, we have A. Now, the dimension will now be square bracket A. Square bracket A. What is the dimension of area? I'm not going to overstress too much here. If you missed our last class, make sure you go and take it. Join this platform, become a diamond level member. I repeat, become a diamond level member. Activate that level. Nigerian currency, it is 4,000 naira only. And that payment is monthly. So you see, I'm really giving it to you on the platter of gold. It's as good as free of charge. That will help you to get access to all of our classes, because some of our lessons are meant for channel members only. If you are joining this channel to get access to all the lessons on this platform, join on the diamond level. You can join on the platinum level. You get access to some of the lectures. Others, and even most others, you may not get access to them. All right, let us move on. So we already learned from last class that area is length times breadth. So from there, remember the formula, the derivation. Length times what? Breadth. If area is length times breadth, it means that you are going to get the dimension of area from the dimension of length and the dimension of breadth. And I remember teaching you in that last class that breadth is also length related. I talked about breadth, width, thickness, height, distance. All these things are length related. It means that they have the same dimensions as length. So if the definition of area, if the derivation of area is length times breadth generally, therefore the dimensions is going to be the dimension of length and the dimension of breadth. And we know that the dimension of length is L, the dimension of breadth is also L. So that the dimension of area will now be length times length, which will give you length square. Length raised to the power 2, square length. As simple as that. Number 2. Mind you, you can never write it like this. Oh, you cannot write it like this. It's not allowed. You see, each symbol in dimensional analysis should appear only once. I repeat, each symbol in dimensional analysis should appear only how many times? Once. That is why, although the derivation is length times length, you can't leave it this way. You write it as length raised to power 2 using the law of indices, multiplication law. Pick one of the lengths because they have the same basis, and then add the powers. 1 plus 1, this is power 1, this is power 1. You get power 2. Let us look at volume as the next one. So this is going to be dimension of volume, V. Volume from our previous class, we defined it as length times breadth times height, something most of us already know. So to get the dimensions of volume is going to be the dimension of length times the dimension of breadth times the dimension of height. Length, breadth, height have the same dimension. Therefore, it's going to be length times length times length. And that will give you length raised to power 3. Please permit me to check the network situation. Let me be sure that you guys are still on. Good. We are moving on. Remember, Mary Cynthia, I just saw something where you wrote it as length times length there in your comment, okay? It's okay. But remember what I said. You are not allowed to leave it like this. This is the derivation. This is the derivation. The dimension itself, look at it. Are you following, right? I'm just showing you this so that at least you can see some things I'm trying to obtain. Otherwise, I shouldn't have shown this. We can just work it with our brain, and then I will just write the dimension here. However, in our last class, we've already written all these formulas. These are just the derivation. If you are asked the dimension of area, it is square length. You don't write it like this. Take note. You don't write it like this. You write it as cube length. Each symbol is expected to appear, how many times I said? Once. Once, okay? So let us move on to another quantity. I'd like us to look at the dimension of density. Density. We use this symbol to represent density, so we are looking at the dimension. Density is defined as mass over volume. Mass per unit volume. So to get the dimension, it's going to be the dimension of mass all over the dimension of volume. And the dimension of mass, it is going to be m all over volume, where m is the dimension of mass over volume. Dimension of volume is cubic length, L to the power of 3. But then, let us take our mind back to the definition of dimension. Remember, we define dimension as a way of expressing a quantity as product. Take note of that. That is why I highlighted those key points in the definition. Dimension is a way of expressing a quantity as product, not as quotient, not as division. This thing is in quotient form, in division form. Normally in dimensional analysis, we don't allow it to be in that way. Am I communicating? You must write those symbols as product, as multiplication. Therefore, this m all over L cube, this L cube will be taken up to multiply m. And of course, if it is going up, I've explained all these concepts when we're dealing with the unit of derived quantities. If L cube goes up, you're going to get m times L raised to power minus 3. This is the dimension of volume. This is the dimension of, this is the dimension of density rather. M L raised to power minus 3. Take note, when I am done, I'm going to wipe all these derivations I'm showing you. I'm going to wipe them. These are the things, we refer to as the dimension. You don't write it this way. Take note. Number 4, let us talk about the dimension of speed. Speed. Somehow, some will still use V for speed. So the square bracket on that V, meaning dimension of speed. Speed is defined as distance over time, the rate of change of distance. So distance over time gives you speed. Which means that to get the dimension of speed is going to be the dimension of distance over the dimension of time. And the dimension of distance is length related. I've said that time and again. Therefore, the dimension of speed will be dimension of distance, which is length, all over dimension of time, which is capital T. And again, you know, you are not allowed to leave dimension in quotient form, because by the definition is a way of expressing a quantity as product, as multiplication of symbols. Therefore, this T will go up to multiply this L. And of course, when denominator is going to numerator, like I said, the sign of the power will change. Here, this T is raised to power 1, raised to power plus 1, positive 1. If it goes up, it will become LT to the power of minus 1. That was what happened to this power 3. Once LQ goes up, this positive 3 will change to negative 3. Number 5, velocity. Again, we use V for velocity. Velocity is defined as the rate of change of displacement. Velocity is simply displacement over time. And displacement is also something about distance between 2 points. The only thing now is that it has a specific direction, where we now talk about the concept of vectors. Don't worry, we are coming to vectors. We're coming to vectors. It's not yet time, okay? So, displacement is simply length related. Displacement is what? Length related. Now, from the definition, velocity is displacement over time. And displacement is length related over time. Dimension of time is T. And of course, you know the rule. You can never leave it in division form. So this T will go up and you still have something like this. What have we seen? The dimensions of speed and the dimensions of velocity, they are the same. They are what? The same. Mishra, I am from India. Bye, sir. I subscribe to your channel. That's good. Thank you for subscribing to this channel. And always stay tuned. Come back and learn. Always. You will love it, okay? We are moving on to the next quantity. You know, your examiner can ask you which of the following quantities have the same dimensions. Here we have established that speed and velocity, they have the same dimension. Let's talk about acceleration. Acceleration A. Acceleration is defined as the rate of change of velocity. So it is simply velocity over what? Time. If acceleration is velocity over time, it means that the dimension will be obtained from the dimension of velocity over the dimension of time. What is the dimension of velocity? Look at it. So it's going to be LT to the power of minus 1 all over the dimension of what? Time. Velocity over time. You know that a symbol in dimensional analysis cannot appear twice. It is not allowed. A particular symbol can only appear once. And again, you know that in dimensional analysis, these symbols are not expressed, are not written in quotient form. Rather, you write them in product form. For that reason, this T raised to power 1 will go up. If it is going to meet the numerator, of course, you have to use division law of indices. I will soon be holding a live class on indices, by the way. Okay? This week, we are going to have that class. If this T raised to power positive 1 goes up, let me just do some stressful something. It's not necessary anyway. It's going to be LT raised to power minus 2. But just in case, LT to the power of minus 1, if this T to power 1 goes up, it will become T to power minus 1. So here you have the same basis, TT. Pick one of them and add their powers. Minus 1 plus minus 1 will give you minus 2. So the dimension of acceleration is LT to the power of minus 2. Let us look at another quantity, number 7. We're going to look at the dimension of force. Force. Dimensions of force. By definition and derivation, force is the product of mass of a body, of an object, of a particle, and the acceleration of that object. So force is simply mass times acceleration. Therefore, to get the dimension of force, it is going to be the dimension of mass times the dimension of what? acceleration. What is the dimension of mass? M times, what is the dimension of acceleration? Look at it here, LT to the power of minus 2. Therefore, the dimension of force will simply be M L T to the power of minus 2. We are moving, and I hope we are learning. Let us look at the dimension of work. I'm going to wipe from here, no time. Dimension of what? Work. Remember, like I said, you don't need all these derivations. Well, will I say you don't need them? You need them because you need to understand how these dimensions came up. All right? How they came up. So that's why I showed you the derivation. Please, whenever you are asked to write the dimension of a particular quantity, what's the dimension of a given quantity? If you choose to derive it, you do it as a rough work. Except if the examiner says you should derive it, then you can now be showing all these things and doing. Let us assume in a computer-based exam, CBT, where you have options. Of course, you don't need a derivation. Because the examiner can simply ask you, what is the dimension of, dimension the quantity. Maybe if I ask you, what's the dimension of density? You simply say it is ml raised to the power minus 3. Do not go deriving density is mass over volume. Therefore, dimension of mass is L over dimension of volume is L cubed. Applying division law of indices. Of course, taking T up, you have LT raised to the power minus 3. You don't do all those things. Except if you're asked to derive it. The dimensions itself are all these things we wrote. Are you following here? Okay, let us move on to dimension of work. You see, I am pretty fast a bit, as I can anyway, but I'm still slow because we've treated the foundation of this from our previous class. That is why you should not miss our classes. Please don't. Is network disturbing from that end? This one has peaked and it is showing. This device I'm using, the track, has peaked and it is showing. You can see that. So I don't know, maybe from your end, Mary Cynthia, maybe network is disturbing from that end. Let's check. I think it is still on. Still on. Okay. Remember though that at the end of our live classes, a copy of the video will be made available. And to get access to them, you become a channel member, you'll get access to them. Join us on the GMAT 41's diamond level. From September 1, each of our classes, a topic will be broken down into 2 as much as possible. The first part will be for the public, everybody. The second part, which, in most second part, that is where serious calculations might come in sometimes, or other fundamental concepts. It will be for channel members, which means to access the live class, you would be a channel member first. Please become a channel member. It's a way of supporting this channel if you love what this channel is doing. Okay? Then your likes, your comments, your shares, share our classes, share our videos. All these, they mean a lot. These are ways you contribute and support this channel. Don't forget also you can give one-time support. For example, this live class that is going on, if you check around that chart after that emoji icon, you would see currency icon there. If you tap on that currency icon, you can send GMAT 41 super stickers, super chat. Those ones are just one-time support. Anything at all you feel like to use in supporting this channel, the choice is yours. I would gratefully appreciate that. Then you have membership. That one, like I said, is monthly. If you join on diamond level, for example, which is 4,000 Naira Nigerian currency, it will last you until 1 month and then it will expire. You still have to reactivate it again. If you have problems, let's assume you want to join the channel, you want to become a member, but you don't know how to do it, or you're having problems activating it, maybe using your card, you can contact GMAT 41 and you will be assisted, okay? You'll be assisted to activate it. Let's move on, please. Number 8, we're talking about work. Work is defined as force times distance, mathematically, okay? The product of force and the displacement that the force creates. If you have an object here and you move the object from here to here in a particular direction, you have done work. A force will be responsible in moving the object from this point to this point. The product of that force that moved the object and the displacement covered gives you work. So the dimension of work will now be given as from force times displacement, F times ds. ds, if I say maybe something dx, where this dx is displacement. Some persons can use s for it. ds, changing position, right? Giving you distance covered in a specific direction. But I don't want to bring anything calculus here yet. So let me just write it. Force times distance, Fs. Let me use Fs, force times distance. Now, this is going to give us, what is the dimension of force? What is the dimension of force? Dimension of force is mLt raised to the power minus 2. So you fix it here, times dimension of distance. What is dimension of distance? It's still length. So you're now having mLt raised to the power minus 2 times L. That will represent force times displacement. So we have dimension of force, which is mLt raised to the power minus 2 times dimension of displacement, which is L. Therefore, the dimension of work is mL squared t raised to the power minus 2. You can see that this is L times L. You can only make use of one symbol at a time. So this LL, pick one of them and add their powers. Okay. Alina, Miriam, when class starts. Anyway, we'll have a timetable to read. What I always advise you people, although I'm still trying to stabilize the timetable to know a particular time I will be coming on live. Okay. So for now, I'll be silent to that, but I promise that between now and September 1, okay, 2025, between now and September 1, that's next week, I guess, I will tell you when exactly I'll be coming on live for our classes. What you just have to do is subscribe, turn on the notification bell, so that whenever I upload anything, you will be notified. Whenever I come live, you will be notified. But I understand that we should have a fixed time, very important, so that you will also know that also time you are devoting it to your online class. Please give me between now and 1st of September. I'm going to let you know that. We move on to the next one, energy. Energy, dimension of energy. Interestingly, you will find out that the dimension of energy is the same as the dimension of work. Now, for us to establish the dimension of energy, I am going to use one formula of energy. One of the formula of energy we know, this mechanical energy that is divided into kinetic and potential energy, where kinetic energy is 1/2 mv squared and potential energy is mgh. You can use any one of them to get the dimension of energy. And when you do so, you will still get mL squared t raised to the power minus 2. Energy and work, they have the same dimension. Let me quickly prove it for you here. I think I'm going to use this part. Okay, now energy, I can use mgh, but I'd like you to try that one for potential energy. Mass times acceleration due to gravity times height. Mass is capital M. Acceleration due to gravity, the dimension is the same as dimension of acceleration. That is that is Lt raised to the power minus 2. The dimension of acceleration due to gravity, g. Then the dimension of h, height, is L. So if you do that, remember mgh. That m will be capital M, the dimension. G will be Lt raised to the power minus 2. And then h will be L. If you work that out, you have 2L there. L times L will give you L raised to the power 2. So everything becomes M, L raised to the power 2, T raised to the power minus 2. So you can work on that using mgh to get the dimension of energy. I want to use 1/2 mv squared to still get the same dimensions, all right? To still get the same dimension of energy. Okay, so follow as I do that using this. Now, in dimensional analysis, we do not make use of constant multiplier or constant divisor or constant addend or constant subtractand. We don't use these guys. What do I mean by that? A number or a constant is multiplying quantities or dividing quantities. You don't use it in dimensional analysis. You keep it aside. I talked about addend or subtractand. If that constant is added to or subtracted from a quantity, you don't use that constant. Therefore, this 1/2 you are seeing will go off. It has no business in this dimensional analysis. This is a constant multiplier. You are left with mv squared. What is the dimension of mass? The dimension of mass is capital M. What is the dimension of velocity? The dimension of velocity is Lt to the power of -1. So close bracket, Lt to the power -1 is dimension of velocity. Velocity is squared in this formula. So you square that dimension also. Apply power law of indices. This is length times time raised to the power -1, the dimension. And these two quantities that are multiplied, they are raised to power 2. Power law of indices tells us that power can distribute over multiplication and division. So these two will be distributed to L and T raised to the power -1, giving us M, L raised to the power 2, L to the power of 2. Then this T, -1 times 2 will give you minus what? 2. So I have established the dimension of energy, proving that it is the same as the dimension of what? Work. So let us do that and see. It's going to be n L squared T raised to the power -2. No time to waste. I've shown it here already, the derivation. Let us move on. My generator is going off now, right? It's been running since morning because I had a class with our basic scholars, those in basic 4, 5, 6, 7, 8 and 9. That is in our second channel, GMAETS 41 basic class. That one is meant for basic scholars. You can have your younger ones join us. So since that morning, it has been running and I can hear the sound wanting to go off. So let me create a path. Let me create a path for ray of light to come in case the light goes off. Now, let us look at the dimensions of power. Power. Dimension of power, P. Okay? Now, what is the dimension of power? Power is actually obtained from energy over time or work over time. Power is defined as the rate at which work is being done or energy expended with time. So it is energy over time. If power is energy over time, the dimension of power will be obtained from the dimension of energy or work over what? Time. Now, what is the dimension of energy as we have already? M L squared T raised to the power -2. Now we are dividing by the dimension of time, which is T. If this T goes up, of course, you're going to get M L squared T raised to the power -3. This is the dimension of power. And the light is gone. But of course, I know the natural ray of light is brightening here anyway. Alena Miriam, do you take math classes? Would you appreciate a video on permutations and combinations? Yes. All science subject-based works. This channel works on it. Okay, so math, physics, chemistry, and soon biology will soon kick off on this channel. Hopefully from September. Yeah. So Alena, take notes. Math, we do the works on it. Permutation and combination, we have a wonderful video on it already on this channel. So like I've always advised you people, become a channel member. Support this channel, and all you can do, or all you would do once you become a channel member, send a message to GMAETS 41 on this contact. Look at it, this contact. +234 8064462385. send a message to GMAT41 on WhatsApp, indicating that you've joined Diamond level. You'll be added to our WhatsApp group specifically for those on Diamond level. You make your request there. When you make your request, we attend to it. Assuming that you need video lessons on permutations and combination on this channel, it is here. But maybe sometimes because of we have so many works on this channel now on physics, on chemistry, and math, in fact, like full course outlines, full textbooks analyzed in video format. Maybe you go into search and search and search. This is why you want to support this channel more. Become a channel member, and then when you make certain requests, we just send you the link. We'll show it to you. Okay, that's good. Mohammed Umar, interesting thing is work, torque, energy have the same dimensions. Yeah, you are very correct. They have the same dimension. Impulse, momentum, they have the same dimension. Yeah, we're working on that. Let's move on, please. No time. This will take us to another quantity. Pressure. What is the dimension of pressure? Dimension of pressure. Permit me also to use P for pressure. Now, pressure is defined as force per unit area. Definitely. If that is the definition, the derivation of pressure, force per unit area, the dimension of pressure will be obtained from the dimension of force divided by the dimension of area. Now, what is the dimension of force? M L T raised to power minus 2. Now, all over, what is the dimension of area? L squared. If that L squared goes up, because you are not allowed to write dimension in division form, it's not done. If the L squared goes up to meet L raised to power 1 in the numerator, you are going to get L raised to power minus 1. How about you work that out? Because I'll just simply write the dimension here without showing you. It is M L raised to power minus 1, T raised to power minus 2. Remember the definition. Remember the derivation of pressure. It is force divided by area. So you get the dimension from dimension of force, which is L raised to power minus 2, all over dimension of area, which is L squared. Apply your division law of indices. You will get the dimension of pressure to be this quantity. Let us look at the dimension of momentum. Momentum. Again, I'm going to use this symbol anyway, a falling P for it. Dimension of momentum. Okay, good. Momentum is defined as the product of mass and velocity. Momentum is defined as the product of mass and the velocity of the object. So to get the dimension of momentum, it is simply the dimension of mass times the dimension of what? Velocity. And what is the dimension of mass? Capital M. What is the dimension of velocity? LT raised to power minus 1. Mass times velocity gives you momentum of a quantity. Am I communicating? So to get a dimension is simply mass times dimension of mass, which is capital M, times dimension of velocity, which is LT to the power of minus 1. Look at it. What about the dimension of impulse? Impulse I. Impulse is defined as the product of force and time. When, two things impact, when two things hit, when they collide, you talk about impulse there. So the product of force and the time during which the impact, during which the collision occurred, that gives you what we call impulse. And now, from that, we now find out that impulse will be force times time. So the dimension of impulse will be obtained from the dimension of force and the dimension of what? Time. Multiply both of them. Force is MLT raised to power minus 2. And of course, time is T. So if you're talking about the dimension of impulse, of course, it's going to be ML, force times time, which is MLT raised to power minus 2 times T, which will give you MLT raised to power minus 1. MLT raised to power minus 1. This is cool. It simply means that momentum and impulse have the same dimensions. Of course, someone talked about that. Mohammed Umar talked about that earlier, that they have the same dimensions. Okay, and that's correct. You can see the derivation on the board. Let us look at another one, stress. 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 I'm going to use this symbol, tau, for stress, although this symbol is also used for torque. What is the dimension of stress? If you come to this topic, elasticity, you will learn that stress is force divided by area. Stress is force divided by area. And that takes us to pressure, because pressure is also force over what? Area. Clearly then, the dimension of stress is going to be the dimension of force. Let me show you, mLT to the power of minus 2 divided by the dimension of area, which is square length, at least. So you know how I got the dimension of pressure. From here, this would give us m L raised to power minus 1, T raised to power minus 2. Because this L square will go up, you apply division law of indices there. We are moving on. We are moving on. So you see, there are many more. Like I said, we cannot exhaust the list. And of course, you want to work on this on your own. If you have any problem anytime on dimensional analysis, dimensions of quantities directly, of course, GMAETS 41 is here for you. And especially if you're a member of this channel, of course, you'll be given much more attention. What do you expect? What do you expect? You have to belong to this school, this online school. Yes. Become a member, join us on the diamond level. Just 4,000 naira only monthly. And the rest will be wonders of learning. Yes. GMAETS 41 on this channel, we are unstoppable. We keep moving so as to train you, to coach you for your A splashes in your examination. And not just all about you just going to smash A's, but you will understand and appreciate what you're learning. Now let us quickly look at applications of dimensions, all right? Applications of what? Dimensions. Applications of dimensions. I'm going to wipe this. I'm going to wipe this. Applications of dimensions. What do we apply dimension to? What are the advantages of dimension? Why do we actually study dimension? I want to talk about the application quickly. Applications or advantages of dimension. Applications of dimension. Applications of dimension. Meanwhile, there are some other quantities that are called dimensionless quantity. I'm going to give it to you as a note at the end of this class, right? Okay, dimensionless quantities, because you're expected to know some of them. Quantities that do not have dimension. But like I said, at the end of dimension as a whole, we'll talk about that. Applications of dimension. What are the various applications of dimension? Dimensional analysis. Now you can put them down. One. You use dimension to test the consistency of an equation or a formula. Dimension is used to test the consistency, the accuracy of a formula. So think about all the formulas we have in physics. I can ask you, are they correct? Are those formulas correct? If you say yes, how do you know that they are correct? The knowledge of dimension can help us to establish the correctness, the consistency, the accuracy of a formula. That is one application of dimension. 2. Dimension can be used to derive a formula. Dimension can be used to derive a formula. The formulas we have in the study of science, we can actually use dimension to establish them, to derive them. I'm going to give you an example quickly. There is this formula T equal to 2 pi. Usually we like using this as an example. This formula is the period of oscillation, period of simple harmonic motion. All right, specifically for simple pendulum. This is the period. And this is the length of the pendulum. This is acceleration due to gravity. You have 2 pi here, right? Now I can tell you that, okay, the period of a particular quantity is equal to m raised to the power x, L raised to the power y, G raised to the power z. Derive the period. Derive the period. The formula, get it. Derive the period. Derive the formula. The formula of the period. Derive it. The knowledge of dimension can be used for this. All you have to do is, from this information given to you, okay, let me introduce K here, and I'll tell you where K is equal to 2 pi. Yeah, because for this guy, that's the condition. K is a constant equal to this 2 pi. All you have to do is find a way to get your X, get your Y, get your Z. These guys, they have values. And I tell you that if you do that, you see this thing, if you do it, X will be equal to 0, Y will be equal to half, Y will be equal to half, and G will be equal, right? Z will be equal to minus half. That's going to be the values of these guys. Once you do that, you substitute and then work it out, you get this formula. The knowledge of dimensional analysis is used to derive a formula. That's another application. Next application is the fact that we use dimensional analysis to establish or predict the form in which a physical law of physics can take. Dimensional analysis is used to predict the form in which a law of physics can take. Those that study physics, in the highest level of it, they deal with this concept. And of course, no wonder they establish lots of formulas and formulas and formulas in physics. The knowledge of dimensional analysis is used because when they are predicting the form in which a physical law can take, they actually apply knowledge of dimension to test the consistency of the law they are trying to predict. If they test for the consistency and it works, fine, they start establishing it. If it doesn't work, dimensional analysis will help them to know that this law you're trying to predict will not work. Although for this level, it might be beyond different scope because, of course, you're not at that position yet to start talking about predicting and establishing certain physics laws. But of course, who knows? Anybody can be a genius and then start thinking out of the world sometimes and come up with certain things. If you are to do that, when it is time to predict and establish these laws, you make use of dimensional analysis. Up Games 2045, hello, you're welcome to join the class, okay? All right, so I have told you or stated 3 applications of dimensions. I've stated 3 applications of what? Dimensions. Use it to test the correctness of a formula. Use it to derive a formula. Use it to predict the form in which a law of physics can take. And we are going to discuss that. Apart from the 3rd application, which, like I said, is beyond us at this level. The first 2, we are going to deal with them a lot with calculations. You won't want to miss out in that. The van der Waals equation of states is given something of this form, P plus A all over V squared, and then times V minus B equal to RT. What if I ask you to get the dimension of this A? Dimension of A is equal to what? What if I ask you to get the dimension of B? Dimension of B is equal to what? What if I ask you to get the dimension of R? Although R is a constant, so let's say, and this is T. T is fundamental quantity already, temperature, so the dimension is theta. R is a constant, so we don't talk about dimension of a constant anyway. Constant is dimensionless. Okay, so dimension of A, dimension of B. What if you're asked to find the dimension of these guys? And once you know the dimensions of these quantities, you can get the unit of the quantities. How do you go about that? Applications of dimension will help us to deal with this. I told you a moment ago, imagine you are given T to be equal to K, M to the power of, let's say, A, L to the power of B, G to the power of C. And you are asked to find the formula, derive the formula of the period. Formula of T will now be what? How do you solve this problem? The application of dimension is used in this. And by the way, dimension is also used to obtain the unit, the SI unit of a physical quantity. Please add it as number 4. Dimension, another application of it, is used to obtain the SI unit, the System International Unit of Quantities. In fact, it is established that dimensions are actually used to get SI units, to get the System International Unit of Quantities, okay? So I want to take note of this concept, right? I want to take note of this concept. So how can you actually solve these problems? If I give you this formula that F is equal to G M1 M2 divided by R squared, how sure are you that this formula is correct? How sure are you that this formula is correct? Who told you that it is correct? If I give you S equal to UT plus 1 over 2 AT squared, it's possible that you've been seeing this formula before. Let's say under motion, second equation of motion. Is this formula actually correct? Why did physicists establish it? Of course, these are equations that are brought under motion. Why are we studying them? Are they actually correct? How can you prove that this is correct? What if I give you something, say sine, open bracket, AT divided by S, let's say AT squared divided by S. What if I ask you to get us the dimension of this A? Dimension of this A. What do you do? How do you obtain it? All of these things are solved using the applications of what? Dimensions. You won't want to miss this class, right? In part 2 of dimensional analysis, I'll be dealing with that. You want to join part 2? I am going to tell you the time in which I'll be coming on live for this class. It is going to hold by 11:30 a.m. tomorrow, Nigerian time, West African time, right? 11:30 a.m. I'm going to hold a class on it. To enjoy the class, become a channel member. Join us on the diamond level. If you have challenges on how to activate your membership, contact GMAT41 on this line. +234. For those in Nigeria, you use 080, okay? 08064462385. If you are in any other country and you want to connect to this class, you want to become a channel member, you love what is happening here, I have shown you a lot of things that the application of dimension is used to determine, to get to solve. If you're in any other country, you want to connect to this class, if you want to activate the diamond level and you're having challenges with it, contact GMAT41 using this, +234. 8064462385. The diamond level is 4,000 naira Nigerian currency. Okay? Tomorrow by 11:30 a.m. The class is going to be from 11:30 a.m. to 12:45 p.m. 1 hour, 15 minutes class. Okay? So make sure you are there in the class. Become a channel member on diamond level, like I said. If you're having challenges on how to activate that level, contact GMAT41. You know the token that you need to use in supporting this channel in order to become a member on that diamond level. And then tomorrow, I'll be dealing with questions on all these things, all right? Thank you for connecting to this class, and I hope you've learned something wonderful. If you have any question, drop it in the comment section. If you have any contribution to the class, drop it in the comment section. At the end of this live class, a copy of this live class will be made available for you. I look forward to seeing you in our next class. However, remember that on this channel, you have wonderful stuff. Go through the playlist and you will be wowed. You will be shocked at what you're going to see there. Especially for you, dear friends. Share the links to our videos to your friends. Invite them to subscribe. Once you subscribe, turn on the notification bell free of charge. When you click that notification bell, a menu will show. Select all. The reason for this is simple. Nothing is there. It's just for you to always get information about our classes. If I upload any video or I come on live, YouTube will notify you immediately. You'll be the first to be notified that GMAT 41 is on now to teach you. What makes you to support this channel in any way is just channel membership, like I said. And it's monthly, okay? Monthly. For diamond level is just 4,000 Naira monthly. And you have steady classes on this channel. So become a channel member. Once you join the diamond level, please immediately send a message to GMAT on this contact so that you will be added to our special group for diamond members. You'll be added to that group. All right, have a wonderful day ahead and make sure you come back and learn more in case there is any point you missed out. Don't forget to share these videos to your friends. Encourage them to join us, okay? And finally, channel membership important. Take care.